Alright. So today is all about websites, and in order to hack websites, you gotta understand how they work. So we're just gonna start with a quick refresher of how things work. Remember that the front end of websites uses three main languages, right? Does anybody remember what they are? What the three main languages for websites are? Anybody? Come on, look at the inspect element. What language is that? Anybody? Know what language that is? Nobody knows what language that is. That is actually kind of sad. Come on, we talked about this. Anybody? Please help a guy out. Come on. What are the three languages? Okay, I'll give you a hint. One of them is JavaScript. Okay. Did we get the other two? Hey, we got it. Thank you, Dine. All right. So basically, the three main ones are HTML, CSS, and JavaScript. Does anybody know what HTML is? What they're used for? Like, what are each one used for in a website? Anybody? What are HTML, CSS, and JavaScript used for? Well, I'll just give it to you guys. Basically, HTML is the basic layout of the page, right? Like over here, these are all like just elements of the page, right? Then CSS is for styling the page, right? Like your fonts, your colors, your like everything style related, right? And JavaScript is for scripting and running of the page, right? So essentially, if you want to like do something when a button's clicked, you would do that in JavaScript. Okay. So, how do we access websites? Well, basically, every time you want to access a website, your computer actually asks another computer for the website, right? So, essentially, all you do is you send a GET request to HTTP GET request, which is basically like, does anybody know what HTTP stands for? It's kind of interesting. Anybody? HTTP basically stands for Hypertext Transfer Protocol. So basically, it's a way of sending text over the internet, right? So essentially, all you're doing is you're asking a server for a text file. It sends you the text file, which is like an HTML file, and then it renders it for you. So the people who are sending you the website don't actually render it for you. Your browser is the one that's actually showing it up for you. So like for example, like if we go to this website, let's just say, and we go to inspect element, and we look at what's going on in the network. Oh, load. Yeah, so you can basically see it's sending all these GET requests, right? What's an example? Yeah, here's a good example of a GET request. Hold up. Why can I not see the stats of it? Well, yeah. Anyway, this is a GET request, and basically, oh, there we go. So essentially, it sent a HTTP GET request. It got back all this HTML, right? Over here, it got back the HTML, and then your browser displays it for you. Okay. So back to this. Basically, the person who's sending the request, right? You are the client, right? Because you're like accessing it, and then the person who's sending you the site back is called the server. Okay. So, which side do you want to keep the internals of your website? Like, um, why, yeah, like, so where should the internals of your website be? Client or server? Any ideas? If you don't want people to know, okay, we got chat message. Server, right? So essentially, you always want to have your like important information about your website on the server side, and you do not want to send it. If you accidentally send stuff to your user, then they figure out everything about your website, and then your website is no longer secure, right? So we could just do a quick example of this. I think I've gone through this before, but I'm not entirely sure. Hold up. Okay. So let's just look at a example problem. So client side again. Okay, so essentially this seems pretty hard, right? We can't just like guess the password, right? But if we actually look over here, we go to sources and we go to index. You can basically see that it sent us the flag, right? Basically, this is bad programming practice, right? Because the server doesn't have all the secret information, right? It sent some of it to the client, and now we could like find the password, right? So if I like, I mean, this might take, it shouldn't take that long, but you get the idea. I could basically piece together the password just by looking over here, just because they didn't do good programming, right? They should keep it on their side, and then when I send them the information, they should check it on the server, not check it like over here. So that's an example of client side, right? Like you do not want to have stuff on the client side that's security related. Okay, cookies. So A lot of people just like know that you're supposed to clear cookies, right? If you want to like log out of stuff. But the reason for that is because cookies is what actually store your your information for a website, right? Like if I log in onto Facebook, right, then I don't want to keep logging in. So all the cookies do is they store that I've already logged in. Like over here, these were my Facebook cookies a while ago, right? And essentially, this just lets you sign in. So essentially, if you had somebody else's cookies, you could just log in as them, and you could wreak havoc. So the idea is you don't want to actually share your cookies with other people, um, since that would mean that they could just like impersonate you because it'll say, "Oh, I'm logged in as this guy already, so I don't need to log in again." Okay, so um, basically, you had to keep in mind that clients can edit cookies. I think there's a good example of this on the same website. Let's see, which one was it? Open to admins. Wait, there was another one that was good. Let's see, what was it? Oh, log on, yeah. Okay. So if I try logging on as like admin or something, blah blah, I get logged in, but I can't actually see the flag. So what we could do is we could look at how they're deciding whether I am actually allowed to see the flag. And essentially, what's good about this one is that they actually do it on the server side, so I can't really tell. But if we go to application, we see all this nonsense. So how do you guys think we could get the flag? Which of these cookies could we change to give it the flag? Come on. Anybody? No? Well, essentially, we could just put ourselves as admin, right? Hooray. Users could edit cookies however they want. And if we refresh it, hooray, we got the flag. Okay. So, essentially, the security thing that we want to do is we want to make it so that cookies can be seen by users and changed by users, but they can't actually make it so that the server thinks that the cookie is legit, right? So, does anybody have ideas how we could use this? If anybody knows any crypto, any ideas how we can make something not changeable? Does anybody know how your computer like prevents or how like people verify whether their downloads are good and not like modified? It's a fun CS trivia thing. How do you make sure that something hasn't been tampered with? Nobody knows. Hint is has to do with one-way functions. Nobody knows. Seriously, that's kind of sad. Okay, well, essentially, whenever you download something, right, it includes something called a SHA-256. Does anybody know what that is? SHA-256. No, nobody. Okay. Well, basically, it's called hashing, right? So essentially, if you hash something, you could prevent people from tampering with it. So essentially, what JWTs are they basically take your data, and then they hash it, and they include the hash with the data. So if I change the data, I can't compute the hash without a password that only the server knows. So we could just look at an example of this, right? JWT scratchpad over here. Wait, could you guys hear my notifications? I'll probably turn those off if you guys can. Hold up. Okay, should be good. Okay. So essentially, if we go to inspect element, we could look at the cookies, and this looks like a bunch of nonsense, right? Like, what are we supposed to do with this? But basically, we could actually go and decode it. JSON web token. Go over here, we put it in, and you can see, right? It basically has our username, and it says that this is a JSON web token, and essentially there's a signature, right? So essentially, we cannot change this without knowing the password, right? Because we can't generate the hash for this. So essentially, what we got to do is we got to find a way to find the password for this in order to change it. And this is an example of good security, right? Like JWTs are legitimately used in websites to check if you're logged in or not, right? So essentially, what I could do is if I find this password, I could hack the website. And what we're gonna do is we're gonna find the password. That's why you also got to choose good passwords. So I basically have this VM running on my computer. So if we just go to that, Okay. One day it'll work. Okay, there we go. Whoops. Okay, so essentially what we could do is we could store this in a file, pass.txt or something, and we can put it in, right? And essentially, I have this password cracker thing called John, and we could do dot John password.txt dot dash word list equals what was it? User slash no what? Hold up, let me search something up real quick. Collie word list location. Oh, user slash share slash word list. Isn't that what I typed? Okay, slash user slash share slash word list. And then slash rocku dot txt. Whoops. Okay, then John pass.txt dash dash show. Oops, John pass.txt dash dash show. And you can see, it basically found the password for this. So now we can actually change our username. So we just go over here. Let's just pretend like we didn't know the password and we made this just admin, right? Oops. Bruh. And we try to copy and paste this in. See, it basically says server internal error because our hash is sketchy, right? We didn't have the correct hash because we didn't know the password. But if we actually put in the password and we say I love Pico, and we try to put this guy in, hey, and we got admin and I spelled it wrong. Bruh. Okay, well if we fix this, it should be fine. Okay. Why can't I change this? Hold up. Okay, there we go. And we refresh, and hooray, we got the epic flag. There we go. Nice. Alright. So, that is about all we're going to talk about for cookies. Now we get to talk about Sql injection. Okay. So, databases are basically how websites need to store information, right? Like, you can't just have a website without the data stored anywhere. So, essentially, a lot of them use this language called Sql to access them, right? So essentially, Sql has a bunch of things called tables, and each table has columns and rows. So for example, there's a column, right, named customer ID, there's a column named customer name, and each of these rows has like entries with data in them, right? So essentially, queries look like this. You select some columns from some table where some condition is met. And if you want to comment stuff out, you can use dash dash, and you can use slash star. So if we go here, and we look at the customers table, okay, so if we just run this Sql, it selects the entire table, right? Select star means select all from customers. Okay. Does anybody have an idea how we could select all the guys with from Mexico DF? Any ideas? No ideas? Sad. Okay. Well, essentially what we could do is we could do from customers where city is equal to Mexico. I don't know if that's gonna work, but we could try it. Oh, did someone say it in chat? That's why. Okay. Oh no. Yeah. Okay. Chris was saying hash. My bad. But yeah. That is good. And we could basically do run SQL. Oh, it doesn't like Mexico. Let's try not being Mexico. Hold up. So we could select from London. Why not London? Let's do that. Oh. And that is the call. Okay. And hooray, we got all the guys from London. Okay, and what else could we possibly do? We could only select their name, customer name. Try running that. And hooray, we just got their customer name. Very nice. So SQL is really good, right? You have this table and you can easily get records from it. Okay. And now we can start actually hacking stuff. So if you have a username and password table, how would you want to check a pair of username and password? Anybody have an idea how we might want to check a username and password? Oh, get a few rows at a time? Wait, wasn't that what I did? Wait, Albert, did I answer your question, or do you have something else, some other question?
Like, can you get a few rows like at a time?
Yeah, so if I want,
Mhm.
so I got like this time I only got six, right? I only got six rows, but if I wanted to only to get one, right? I could say limit one and only return the first one that it finds, right? If I do
Right.
select star limit one, it'll only get me one. If I do like limit six, it'll get me the top six rows of the table, that kind of stuff.
Mhm.
Yeah.
Yeah.
Okay. So if I wanted to check if some person who enters the username and password if it's correct in this table, how do I do that? How do I check whether an entry with a certain username and password exists? Any ideas? So let us pretend that in this the username is customer name, or sorry, the username is customer name and the password is customer ID. So how do we want to check if an entry exists for a certain username and password in this case? So let's say I enter the password around the horn. I mean the username that and the password that. How do I check if this is a valid pair? Anyone have an idea? Well, what's our condition gonna be? Anybody? Well, basically the condition is we want to check whether the customer ID equals around the horn, and we want to check if the password equals 4, right? So essentially, in this case, we would say where customer ID equals 4 and customer name equals. By the way, Sql is like case insensitive, so it's kind of OP. But if we do around the horn and we do that, we run the Sql, and hooray, we got an entry, which means that the password's valid, right? If we put the incorrect password, if we put 5, then essentially it wouldn't give us the result and we're dead, right? So essentially, this is how a lot of websites check whether your username and password is valid. So let us move on from that. Okay, so basically this is an unsafe way of running a SQL statement. Basically, does anybody remember why this is unsafe? Why it's unsafe to have these plus signs over here? We kind of covered it in our intro to cybersecurity lecture, but does anybody remember why this is dangerous? Anybody? Why is it dangerous to put user input directly into something you're gonna call? Nobody? Come on. Exactly, Bobby is gonna drop the table. Very nice. Yeah. Yeah, I should have included that. Wait, let me see if I can find that xkcd comment. I mean, no, that xkcd SQL injection is very good. Oh, yeah. So basically, the idea is like, hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way, is your son thing actually this? So basically, what this does, could anybody tell me what you guys think this entry for username will do? Anybody? Anybody? Come on, it's fun. Well, yeah, basically like it'll check, oh, if username equals to this, it'll put it'll end that statement and then it'll drop the tables completely. So it'll basically delete their entire database. Kind of insane. So that's a pretty fun one. Okay. And essentially that's how you drop a table. Does anybody have an idea how we could log in without knowing somebody's password? So essentially, we want to ignore the password check. So what can we do to ignore something in code? Just generally speaking, how do you ignore something in code? Anybody? Nobody knows how to ignore stuff in code? Come on. This is the easiest question of today. Nobody. Okay, well, essentially you could comment out code, right? So essentially, if we do comment it out, we could put admin as their username and then comment out the rest, and then it looks like this. That's what it's executing, right? So all it does is it finds admin and it doesn't even check our password. So we could just log in like that. And I think they have another cool example of this. Irish name repo. We go over here, and we go over here. Admin login. And we could try our thing. Well, okay. Basically, the first way to figure out whether something is SQL injectable is if you do that, and you get like this error, right? Or if you do that, then you say login failed because it got messed up. But what we could do is now we could try our thing where we comment the stuff out after it. And hooray, we got in and we got our flag. Very nice. Okay. So basically there's some defenses, right? You could either have Sql filters, which basically sanitize the input, right? They find stuff that is clearly Sql injection and they take it out. Does anybody know any problems with Sql filters? Why they might be a bad idea? Should just use Sql filters? Like why it might be bad just to try to find everything that might cause a problem? Any ideas? Well, basically the problem with that is that you actually had to know every single thing that might cause a problem, right? And if you miss one single thing, then they might still be able to like hack it, right? And that was one of the problems on this year's Pico, and you're trying to find a creative way to hack it. Um, and that's basically what she's saying to do. Like, please sanitize your input. That basically means don't let like random SQL injection in. Okay. Then escaping input basically means you could escape characters that are going to be problematic. It's basically the same as sanitizing, but both of these are problematic. But this one is kind of OP because basically all you do is you put a question mark and then SQL puts in the argument for you so that, but it treats it as an argument. It doesn't actually let it impact the statement itself. So it's kind of epic. Okay. And that is all we got for today. So here's the flag. Um, I think. Hold up. If you guys are interested in this, you guys should try out the Pico web exploitation and stuff. There's a lot of problems and they're all pretty cool. So if you want to try that, do that. I could show you a couple more. One thing I was wanting to show you guys. So I said at the beginning that like you could do whenever you want to get a website, right? Your computer sends a GET request and it doesn't actually show you this whole website. That's not what a GET request does. So if I want to show you like exactly how a GET request looks, I could just do curl-x get, and we could put in like some URL. And you can basically see, right? This is what a GET request sends, right? I'm just sending a request to a server, and it's sending me just this text file back, right? So what's cool about this is that like your browser is what's doing all the rendering, okay? So that's why like Firefox and Google Chrome and everything, they display things slightly differently. So it does depend on browser unless you're pretty careful with your coding. So that's another cool thing you could do. Curl is a way of doing GET requests without actually using your browser. Okay, that is it for today. So thank you guys for coming. If you guys have any questions, feel free to stick around. But other than that, we are good.